What's up, Math 1? This lesson's on 9.b, which is I can solve a system using the graphing method. Now, going back to earlier in the chapter, we learned about what a system was. And a system is basically two or more equations with two or more variables. And even more important is understanding what the solution to a system of equations is. And that is the ordered pair that makes all of the equations true. Now, if you take a linear function, right, and you graph it, it'll be the graph of a straight line. And this straight line is made up of an infinite number of points. Now, when we graph the second line, right, it's made up of an infinite number of points. Now, there's two things here. One, right, the solution to this system will exist at the intersection of the two lines. That is the ordered pair that will make both linear functions true. Now, at the same time, if you think about it, how many times will two lines intersect? Once, which means unless it's a special case, a system can only have one solution. Okay? So now, if we look at it, here they're giving you a system of linear equations. And they give you the graph of the linear functions. So basically they say, graph this function, right, which is this line here. Then they said, all right, let's go ahead and graph this line here, which is that. Now, what is the solution, or what is the ordered pair that would make both of these equations true? And if you look, that solution will exist at the intersection of the two lines, which happens to be the ordered pair 5, 2. And if I take that ordered pair and I plug it up in here, so if I say the solution is 5, 2, it's telling me x is 5, y is 2. So does 2 equal 2 times 5 minus 8? 2 equals 10 minus 8. 2 equals 2. That checks off. The next one is 3 times 5 plus 5 times 2 can equal 25. Well, 15 plus 10 is 25. That checks off, which tells you that the solution to this system is 5, 2. So when you solve a system of equations using the graphing method, starting from scratch, right, there's a couple of things you have to keep in mind. One, you have to graph both linear functions correctly. And two, you have to graph them perfectly straight, right? Because if your graph is off a little bit, it could give you the wrong ordered pair, okay? So if you remember graphing lines, if you are in slope-intercept form, meaning your equations are in y equals mx plus b form, it is best to use the slope and y-intercept to graph the lines. So for this first line, I know my slope is 3/4. I know my y-intercept is 0, 2. Remember, this is your y-intercept. This is your slope. Sorry. Okay, so I'm going to plot 0, 2. Then my slope tells me to go up 3, right 4. So up 1, 2, 3, right 1, 2, 3, 4. Once I have my 2 points plotted, I'm going to go ahead and sketch my line. Now the second line, right? The slope of this, right? Here's my slope, is negative 1/4. My y-intercept is 0, 6. So I'm going to plot 0, 6. Then my slope tells me I'm going to go down 1, right 4. So down 1, right 1, 2, 3, 4. And what's nice about this system is the ordered pair actually, when I use the slope, ends up being right there. So that would be your slope. So my ordered pair solution here would be 4, 5. Now, I should always check this, right? But by plugging it back in, but due to time, we're just going to move on to the next one. Okay, now, this one, the first one, my slope is -3. My y-intercept is 0, -9. So I'm going to plot 0, -9. Then my slope tells me I'm going to go down 3, 1, 2, 3, over 1. Down 3, over 1. And I'm going to go ahead and sketch this line. Okay. For my second line, right, it is probably best, because this is in standard form, ax plus by equals c form. And if I look, c is divisible by a and b. So using the x-intercept and the y-intercept would be the best method. To find the x-intercept, I'm going to let y equal 0. Right? That'll leave me with x equals -10. So my x-intercept, -10, 0. The y-intercept, I'm going to let x equal 0. So that would give me -2y equals -10. When I solve for y, I get y equals 5. Ordered pair, 0, 5. So now I'm going to go ahead and graph this line. Now notice, right? I am going to look at this ordered pair. Now, I have to make sure my lines are perfectly straight in order for me to have the correct, intersection point. Because we may be a little off, right? So -4, 3 is this intersection. We should check these, or this solution. So y equals -3x minus 9. I'm going to plug 3 in. Is 3 equal to -3 times -4 minus 9? Is 3 equal to 12 minus 9? Yes, that checks out. You should check both. So I'm going to plug it into the other one. So -4 minus 2 times 3, will that give you -10? Is -4 minus 6 -10? That checks out, right? Therefore, -4, 3 is the solution. All right. Next example. Right away, when I look at this, I know I'm going to look to use the intercepts. 4 is divisible by -1 and 2. So my x-intercept, right, if I let y equal 0, I get -x equals 4. So x equals -4. So my x-intercept is -4, 0. I'm going to go ahead and plot that. The y-intercept, I'm going to let x equal 0. That leaves me with 2y equals 4. And when I divide by 2, y is equal to 2. Ordered pair, 0, 2. Therefore, when I look at graphing this line, plot my two intercepts, and I'm going to sketch my line. Now, the next one, 4 is not divisible by 3. So to graph this line, what we are going to do is solve the equation for y. So I'm going to add 3x, 2y equals 3x plus 4. Then I'm going to divide everything by 2. And you get 3/2 x plus 2. Now that I'm in slope-intercept form, I can gather my slope. I can gather my y-intercept 0, 2. I'm going to plot 0, 2. And then I'm going to go up 3, right 2. And then I'm going to sketch this line. And right away, you'll see the intersection point here is 0, 2. And therefore, your solution is 0, 2. Now, the last one. Remember, you could take any linear function and create a table of values, right? And if I look at this first function, right, they tell you the first equation, the table for it, is right here. The second one, right, the table is underneath that function. So now, where would the solution of this system of linear equations exist? The solution to this system will exist, right, at the ordered pair that's in both tables. So if I go ahead and I start looking and I see, well, when x is negative 5 here, y is 14. Negative 5, 16 here. When x is negative 4, y is 12. Negative 4, 13. Doesn't match up. When x is negative 3, y is 10. Negative 3, 10. Right here, if you notice, this is the ordered pair that's in both tables. Therefore, the solution to this system is negative 3, 10. All right. So do me a favor, go ahead, use these notes to help you with the student practice, and let us know if you have questions.